For the last few years, artificial intelligence has felt like something inside a box. You open a chat window, type a question, wait for an answer, maybe generate an image, maybe summarize a document. That version of AI is powerful, but it is still trapped behind glass. The next shift is different. AI is starting to leave the screen and move into the physical world: factories, roads, hospitals, warehouses, homes, farms, and cities. Chatbots showed the public that machines can reason with language. But language is only one layer of intelligence. The physical world requires something harder: seeing, moving, touching, planning, recovering from mistakes, and acting safely around people. A model can write a perfect sentence in a clean digital space. A robot has to pick up an object that is slightly slippery, in a room with bad lighting, while a human unexpectedly walks past it. The timing matters because AI adoption is no longer small. Stanford's 2026 AI Index reports that generative AI reached roughly half of the population within 3 years, and organizational adoption reached a huge majority. That means companies are no longer only asking, "Can AI answer questions?" They are asking a more expensive question: can AI help operate the real world? Once that question becomes normal, robotics stops feeling like science fiction and starts looking like infrastructure. This is sometimes called physical AI. NVIDIA describes it as autonomous machines that can perceive, understand, and perform complex actions in the physical world. That definition sounds technical, but the human meaning is simple. AI is no longer only predicting the next word. It is learning how the world responds when something moves. It has to understand space, timing, pressure, weight, friction, risk, and consequence. This did not begin with humanoid robots on social media. Industrial robots have been scaling for years. The International Federation of Robotics reported that 542,000 industrial robots were installed in 2024, more than double the number from 10 years earlier. Most people do not see these robots because they work behind the scenes, welding, lifting, sorting, packaging, inspecting, and repeating precise movements that would be exhausting or dangerous for humans. The old robot was impressive, but it usually lived in a controlled environment. It followed a script. Put the object here. Move the arm there. Repeat. The new ambition is different: robots that can adapt. A warehouse robot that handles unfamiliar boxes. A hospital robot that navigates crowded hallways. A farm robot that deals with weather, mud, leaves, and unpredictable shapes. The leap is not from zero robots to robots. The leap is from scripted movement to flexible action. One reason this is becoming possible is simulation. The real world is expensive and slow. If a robot needs millions of attempts to learn a task, you do not want it breaking real objects millions of times. So developers use digital twins and physics-based simulation to train and test behavior before deployment. In other words, the robot practices in a synthetic world, fails safely, improves, and then carries that learning back into reality. Humanoid robots get the most attention because they are easy to imagine. A machine with arms, legs, hands, and a head feels like a character from the future. But humanoids are only one part of the story. The real robotics boom may include delivery robots, warehouse fleets, surgical assistants, inspection drones, autonomous tractors, factory arms, cleaning machines, mobility aids, and robots designed for one task instead of pretending to be a person. This is why the channel's Future City topic matters. The city of the future is not just taller buildings and neon roads. It is a place where more of the environment becomes machine-readable. Traffic lights, delivery routes, energy systems, elevators, security cameras, warehouses, hospitals, and public transport all become data streams. When AI can read those streams and robots can act on them, the city starts to behave less like a static place and more like a living system. Work changes in 2 waves. The first wave is already here. AI helps with text, code, research, design, analysis, and planning. The second wave reaches physical tasks. The World Economic Forum's Future of Jobs Report 2025 found that employers see AI and information processing as a major driver of transformation, and robotics and automation as another major force through 2030. The lesson is not that every worker disappears. The lesson is that the boundary between digital work and physical work starts to move. A job is not only a list of motions. A nurse is not just moving objects. A teacher is not just delivering information. A mechanic is not just turning tools. Human work includes trust, judgment, timing, care, responsibility, and reading a situation that was never written down. Physical AI will automate pieces of work, but the hardest question is which pieces should be automated, or humans must stay responsible, and how much society is willing to trade for speed. There is a reason the world is not already full of general-purpose robots. The hard parts are still hard. Hands are difficult. Batteries are limiting. Motors wear down. Homes are messy. Objects are fragile. People are unpredictable. A robot that works 98% of the time can still be dangerous if the remaining 2% happens near a child, a patient, a machine, or a busy street. In the real world, reliability is not a detail. It is the product. The risk is not only job disruption. Physical AI also means physical surveillance. A robot or smart city system needs sensors. Sensors create data. Data can improve safety, but it can also measure behavior, movement, emotion, productivity, and identity. The future problem is not simply whether a robot can carry a box. It is who owns the data from the room where the robot learned to carry it. Imagine a normal day in 2030. Your package is sorted by robotic fleets before sunrise. Your commute is adjusted by city systems that predict congestion before it forms. A hospital uses AI to schedule rooms, track equipment, and assist nurses with repetitive transport. A warehouse near you runs with fewer people walking long distances and more people supervising exceptions. None of this feels like a movie. That is exactly why it matters. The winners of this shift will not be the people who blindly worship robots or the people who pretend they are never coming. The winners will be people who learn the system early. Workers who understand AI tools. Companies that redesign processes instead of adding robots as decoration. Cities that set rules before the sensors are everywhere. Creators who explain the future clearly enough that ordinary people can see what is coming before it becomes normal. So the real question is not, will AI leave the screen? It already is. The real question is what we allow it to do when it arrives in the world with motors, cameras, maps, hands, and permission to act. A chatbot can give a wrong answer. A physical AI system can move something real. That makes the future more exciting, more useful, and more serious. The next AI boom may not look like another app. It may look like a warehouse that runs differently, a hospital that moves differently, a city that reacts differently, and a home that quietly fills with machines that can sense and act. That is the future signal. AI is leaving the screen. The real world is next. Subscribe to Future Signal if you want the future before it feels obvious.